Hello, my name is Brad Ferraro and I'm the West Coast Regional Manager for CTC. Today we're going to be talking about 4 to 20 milliamp. Today we're going to do a 4 to 20 milliamp overview and go over some of the 4 to 20 milliamp products that CTC offers. Our 4 to 20 milliamp products is part of our Pro line, which has a lifetime warranty on the parts and workmanship. So we're going to do a 4 to 20 milliamp, just a brief overview. We're going to talk about loop powered sensors as well as discuss the signal conditioners, both current and the one that we are releasing. It will be released later next month. So a brief 4 to 20 milliamp overview. The 4 to 20 milliamp current signal is scaled to the minimum and maximum amplitudes. The 4 and 4 to 20 represents zero vibration or no load, and the 20 and 4 to 20 represents the maximum vibration or full load. The signal output is proportional to the overall amplitude generated within a defined frequency band. It does not include data from frequencies outside the band and includes all vibration for both critical and non-critical faults within the band. If you look to the right, you will see an image of a regular 4 to 20 milliamp application. 420 milliamp technology can also measure temperature, pressure, flow, and speed, and can be extended to measure the overall vibration of rotating machines. Adding a dynamic sensor provides a critical measure of the machine's health and is used to catch unbalance, misalignment, broken gears or bearings, and other issues that may not be detected with just a standard 4 to 20 system. The most common 4 to 20 milliamp interfaces are PLC, DCS, or SCADA systems. The drawing below just shows a dual output 4 to 20 milliamp loop power sensor. This is just a sample of a 4 to 20 milliamp alarm setting. There can be at least 3 different current regions that can be defined for an alarm set. Each region will be proportional to the vibration unit. If you look to the right, a good vibration is 8 to 10 milliamps. An alarm would be 12 to 16 milliamps, which would mean that you would have to go and plug in to get a dynamic reading to figure out what the issue with the machine is. And a failure would be 18 to 20 milliamps, which means you should shut that machine off because there could be a catastrophic failure. This slide gives a good representation of 4 to 20 milliamp versus dynamic vibration. If you look at the middle graph, that is an example of an overall vibration outputted by a DCS, PLC, or SCADA system. And then on the left, you'll see a frequency spectrum, and on the right, you'll see a time waveform. Those are for a dynamic reading. So now we're going to talk about loop-powered sensors. 4 to 20 milliamp sensors, or LP loop-powered sensors, use the same type of sensing element as a standard accelerometer, but the electronic board converts the dynamic signal to a 4 to 20 milliamp, which is proportional to the amplitude scaling of the high and low pass filter in terms of RMS or peak value. LP sensors start by selecting only the portion of the time waveform within a frequency band which is selected at the time of manufacturing. This page just goes over some of the options that CTC offers for loop-powered sensors. We offer both top and side exit sensors. We have hazardous area, so Class 1 Division 1 and Class 1 Division 2 rated approvals. We offer single axis, dual output with temperature, and dual output with dynamic vibration as well. We also have 2 outputs, velocity and acceleration outputs. If you look to the right, you will see the configurations that you can use for loop-powered sensors. As I mentioned in the previous slide, all of the configurations for loop-powered sensors must be done at the time of manufacturing. We have 3 different series for LP sensors. The 200 series is velocity sensors, 300 series is acceleration sensors, and the 400 series is dual output with dynamic vibration. Another big thing for CTC manufacturing, we program the boards on the LP sensors, signal conditioners, and proximity probe drivers by flashing them digitally as opposed to using an analog design, which makes the process for manufacturing these much more efficient and gives a better lead time. So now we're going to go over signal conditioners and differences between signal conditioners and LP sensors. So with LP sensors, you don't have any dynamic capability unless you use the LP 400 series with the dual output, whereas signal conditioners has both a 4 to 20 milliamp and dynamic output. Signal conditioners are also field selectable. You can configure them in the field whereas LP sensors are not field selectable. You need baseline vibration readings in order to configure them. For LP sensors, you also need machine accessibility to collect the dynamic vibration on a route if an alarm was triggered. With the signal conditioner, you do not need to access the machine. You can take the vibration reading from the BNC direct. Signal conditioners are, however, a higher cost, and LP sensors are much more cost effective. So this is our current signal conditioner. It's the SC200 series. The SC200 signal conditioner provides process control signals to the PLC, DCS, or SCADA system in 4 to 20 milliamp outputs, along with being field selectable. 0 to 10 or 0 to 5 or 0 to 10 VDC signals that are proportional to the vibration levels that are set within the signal conditioner. The SC200 series also provides a dynamic data to be collected for analysis off of the BNC on the front. You have internal dip switches that allow for easy configuration, and the SC200 series accepts a variety of signal outputs, including acceleration, velocity, temperature, and displacement for proximity probes. If you look at the configurator at the bottom, that is all of the different things that you can change with the signal conditioner. CTC also offers a free configurator on our website. You can download it and understand how to change each dip switch in order to get the configuration that you want for your application. So this is the SC300 series signal conditioner. This is the signal conditioner that has not been released yet by CTC. Some improvements are it's going to have improved power and output isolation. This new signal conditioner has easier capability with data systems. Isolated commons are no longer required when connecting more than one signal to the PLC or analog card input. It also has lower power consumption and decreased heat output. This just shows the terminal blocks for both the SC200 and 300. As you will see, only terminals 9, 10, 11, and 12 are affected. Also 16 on the SC200 is blank, whereas SC for the 300 would be the sensor input for temperature. This is also one of the biggest improvements that we've made with the signal conditioner. As I mentioned, it will be released later this month. Currently, you have to pop open the signal conditioner and configure the dip switches manually to configure it how you would like it per each application. With the new signal conditioner, there is a micro USB connection right on the front. You can simply plug into that USB connection and configure your signal conditioner as needed. This just shows a couple shots of the new signal conditioner. One big thing about the signal conditioner as well is we are going to have a titanium case. This is going to be very similar, the same material that is used with our proximity probe drivers. Our current SC200 series has a plastic case. It also has an integrated DIN rail mount. Thank you for attending today's CTC webinar on 4 to 20 milliamp application. Have a great day.